Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 6.5 entitled Solving Compound Inequalities Involving OR. And today we're going to solve and graph more compound inequalities. And these compound inequalities are going to have the word OR written right in them. And OR compound inequalities, again, are going to have two inequalities, and then they're going to have the word OR in between them. So they're going to look like this. X is less than or equal to, or I'm sorry, x is less than -3, or x is greater than or equal to 10. So on the left side you have one inequality, and on the right side you have the other inequality, and OR is in the middle. So it's nice to know that these are OR compound inequalities and that they'll have the word OR directly in them. So any other type of compound inequality is automatically going to be an AND. Now we'll still solve each side or each part of the inequality. So we'll solve the left side and then the right side. And then we'll still get our two answers. We'll mark them on a number line. We'll have open and closed circles, or both the same or one of each on our number line. And this time when we shade, we're going to shade in opposite directions. And I like to say that you shade away, kind of like oars on a boat. The oars on a boat kind of stick out on either side. So that's kind of what it looks like when you make an OR compound inequality. Now in example 1, before we actually start solving any type of compound inequality with the word OR, we're going to go through a couple conceptual examples where they just want us to write the inequality statement and then graph it. So for part A, we need to write a statement for all real numbers less than -3 or greater than 6. So I need all the numbers less than 3. So this is going to be on the left side of my inequality. Then I'll have the word OR. And then on my right side, I need all the numbers greater than 6. So to write all the numbers less than -3, I would say x is less than -3. Or, I'm going to put the actual word or, all the numbers greater than 6. So x is greater than 6. So there's my compound inequality. I have one inequality on the left, one inequality on the right, and the word or is in the middle. So when I graph this, I'm still going to have -3 and 6 on my number line. We need a number that's somewhere in the middle, so you can put 0 in there. I'm going to have an open circle on both of those. And if I shade everything less than -3, that's to the left, and everything greater than 6 is to the right, so you can see now how our graphs are going to be shaded in opposite directions. We shade away. For part B, I need all the numbers greater than or equal to 1 or less than -5. Now here is kind of confusing sometimes because you do have two ors in this sentence. So you're not really sure which one means the or for the inequality. But if we read it again carefully, it says all the numbers greater than or equal to. So this or goes with the greater than or equal to. The other or is my compound inequality or. So you have to read these statements carefully and make sure that you get the or for the compound inequality in the right spot. So to write all real numbers greater than or equal to 1, I would have x greater than or equal to 1, or all the numbers less than -5. X is less than -5. Now notice that for these OR inequalities that we've written so far, we can have less thans and greater thans, and they can be in any order. When we were dealing with our compound and inequalities, they always had to be less thans. Both of them had to be less thans. Okay, so that's another difference between the two inequalities. And when I graph this, I need a -5 and a 1 on my number line. You can put another number in there somewhere. 0 is easy. I need everything greater than or equal to 1. So I want a solid circle, and I'm going to shade to the right for the 1. Everything less than -5. So I'm going to have an open circle on the -5 and shade to the left. Okay. So when you're doing your OR compound inequalities, you should always be shading in opposite directions. Now there are some special cases where you might shade the whole number line, and that might be a situation where you have all real numbers or there's actually no solution, but we're not going to see any of those today. So for today, when you're shading, you should be shading in opposite directions on your number line. Okay, there should be a gap, an empty space in the middle. And if it doesn't look like that, then go back and check your work. You might have missed a sign change somewhere. Okay. Okay, for example 2, we have an A, B, and a C. And we're going to solve these compound OR inequalities and then graph their solution on a number line. Now again, we can put a little pink line here to separate the two concepts. We're going to solve the inequality on the left and then the inequality on the right. Most of the time, these are going to be 1 or 2 step inequalities that we're going to be solving. So to solve this one for x, I'm going to add the 1 over to both sides. So I'll have x is less than or equal to -2. Or, now I'm going to do my work for the right side. Again, over here I'm solving for x. I have a new statement now. So I have to subtract the 3 to get that x by itself. So x will be greater than 5. So that's my solution there. Those are my two solutions that I'm going to put on my number line. So I'll have a -2 and a 5. I want a solid circle on the -2, and I want to shade to the left, everything less than it. Open circle on the 5, and shade everything greater than to the right. Now you can have one circle be open and one circle be closed. That's okay. That doesn't mean that you did something wrong. And if we double check our graph, notice I'm shading in opposite directions. I've got this empty space in the middle here, so it looks like everything is correct. Okay, for part B, again, we can put this little divider here if we'd like to kind of separate the two inequalities. And on the left side, I have -x, or -7x is greater than 42. So I'm going to have to divide by a -7 to get that x by itself. Now there I'm dividing by a negative number, so I have to flip my inequality sign. And on the right side, I have x divided by 5 is greater than or equal to 5. So to get rid of that dividing by 5, I have to multiply by 5. Kind of scrunched on room there. But we'll have x is greater than or equal to 15. And then I want to put the word or in between them. So when I graph those on my number line, see I'll have a -6 and a 15. So I'm going to open circle on the -6, and I'm going to shade to the left. Closed circle on the 15, and I'm going to shade to the right. Okay. Now, usually if you're doing everything correct, the smaller number goes on the left side of your number line, the bigger number goes on the right, and then you shade to the left on the left side of the number line, and you shade to the right on the right side of the number line. So those are good observations to make as well. And for part C, our last one here. Now these are a little more complicated. These are each two-step inequalities. Now I'm going to put that divider in, but I'm going to make it yellow this time so it's not as obnoxious as that dashed pink. Okay. Now for my inequality on the left side, when I'm solving for x, I'm going to have to do two steps. I'm going to have to subtract the 1 and then divide by 2. So I'm going to subtract the 1 and subtract the 1. Now it's good to think of this little or as kind of being a divider. So that way I don't start subtracting 1 and subtracting 1 and subtracting 1 to the whole other inequality that doesn't have a +1 that I'm trying to undo. So having that little divider there is a good visual to kind of stop and make sure you only do the subtracting 1 on the left side. So then I'll have a 2x is greater than 12. And then I have to finish isolating the x by dividing by the 2. So x is greater than 6. Or on the right side, I have to solve for this x. Now this x is on the left side of my inequality. So when I finish solving, I'm going to have to take a moment and flip my inequality around. And first thing I have to do is subtract the 3. And again, there's that yellow divider, so I don't want to subtract 3 anymore. I want to stop right here. Okay, negative 18 minus 3 more is a negative 21. It's greater than 7x, so the 3's are gone. And then I'm going to divide by 7 to finish isolating the x. So I'll have negative 3 is greater than x, but I need to flip that around. So x and negative 3 are going to switch places, and then the inequality is going to flip. So my answer is actually this part right there. Those two combined are my answer. And if I graph that on our number line, I'll have a negative 3, and then a 6, and 0 will be somewhere in the middle. And I want an open circle on the 6, and I'm going to shade to the right. And an open circle on the negative 3, and I'm going to shade to the left. So take your time when you're solving these problems. It's okay to use a highlighter to kind of divide the two problems. Make sure that you're showing all your work. Remember all those characteristics of multiplying and dividing by a negative number that flips the inequality sign, or rewriting the inequality and flipping the inequality sign. But your graphs should all be shading away today. You should be shading in opposite directions. Shade to the left and shade to the right. So practice these problems. Make sure you show all your work. And if you have any questions, come on in and see us before school.